it. We're going to take a look at these two different functions, and I'm going to graph them. The trick here is that we're going to do it without using a graphing calculator, that we use the transformation rules to do it. So let's jump into this guy. All right, I am going to start by graphing my parent function. Right here I have the quadratic, that is the function family name. This is a quadratic function. The parent function equation is f of x equals x squared, and that's the graph that I drew. So we always start at the origin for the parent. If I have an input of 1, 1 squared is 1. If I have an input of 2, 2 squared is 4. Once I get these first three points on there, then I just reflect them to the other side. Now, describe the transformations. I see in my equation a 2 out front of the function, the 2x squared. That means I have a vertical stretch of 2. Next up, I have this minus 3 on the outside, meaning it's not attached to that x squared. That would be down 3. Okay, so now it says to graph the function using the transformation rules. Okay, I'm going to start with the vertex. I always like to start with the vertex. And then it says a vertical stretch of 2 down 3. I'm going to start by moving it down 3. So 1, 2, 3. And that's where the vertex now sits. This next point, I'm going to also move it down 3. 1, 2, 3. So it would be here, except it's not there anymore because there's a vertical stretch of 2. So from my vertex, instead of going out 1, up 1, I'm going to go out 1, up 2. That shows you that vertical stretch of 2. Now I'm going to move this next point down 3 places. Now that would have me sitting right here. However, remember we have a vertical stretch of 2. So the distance away from the vertex right on my parent is 4. I have to double that now. So instead of going out 2, up 4, I need to go out 2, up 8. Remember, our vertical stretch means our y values doubled. So 4, 5, 6, 7, 8. All right, now I'm going to reflect the points across the axis or line of symmetry, which is still the y-axis, and draw my beautiful parabola. And there you have it. All right, let's try this next one on the right side. This one is 1/2 x minus 3 quantity squared. We again have a function family of a quadratic, and the parent function equation again is f of x equals x squared. So this number out front, that is our a value, and I see that it is 1/2. That means I have a vertical shrink by 1/2. This minus 3, it's inside of the grouping symbol, and if you recall, inside of the grouping symbol, that's your left and right, and it's what I like to call opposite world. So the minus 3 is actually right 3. Now let's go ahead and graph it. I'm going to get my parent function up there. Okay, so I'm going to take each of these 5 points, I'm going to shift them to the right 3, and then I'm going to halve the y values. Take half of what the y values currently are. So to the right 3, I'm going to start with my vertex, 1, 2, 3. My vertex now sits here on the x-axis at 3. This next point up, 1, 2, 3. Now instead of being here, right, that's no stretch or shrink, we actually have a 1/2. So I'm going to take half of that distance from the y, and I'm going to get rid of this other little guy. And now take this next point up here, 1, 2, 3. Now instead of being y equals 4, y now equals 2, right? Half of the y value. So now let me get rid of this other point. That's not the correct point. Here is my axis of symmetry. So now I'm going to simply reflect these other 2 points across a distance of 2, and I can draw my beautiful parabola with a vertical shrink of 2, vertical shrink of 1/2, and there you go, all done.